Algebra 1 students. This video is going to cover extreme values, maxes and mins of linear functions in particular, but the information applies to all families of functions, regardless of what they are. So the first thing that you see that I've written here is that extreme values only occur on finite intervals, okay? A finite interval has a beginning and an end, as you see in this picture on the left, okay? Finite interval with endpoints, okay? This interval, when you see a graph that goes from one end of your graph window all the way to the other end, this interval is infinite. In the case of a linear function, infinite intervals cannot have maxes or mins, okay? You can have maxes and mins on infinite functions depending on what shape they are, okay? Parabolas have maxes or mins, and we're going to learn about that next semester, even though they are infinite functions, okay? But in the case of a line, no, you can't have a max or a min. You can only have a max or a min for linear functions when you have a beginning and an end. Maxes and mins have to do with y values, okay? They have to do with what the y value is at the maximum, at the place where at the x coordinate, we care about the y. We express maxes and mins as y equals whatever it is. Okay? Here I could say this was y equals -2 if I felt like it. Here I could say this is y equals 6. Right? It's positive. So that is one part that's another characteristic of functions that we need to go over. And just like I was saying a minute ago about the parabolas, here's actually a little picture I drew of a min and a max, okay, on an infinite, even though this goes on, these parabolas don't have endpoints. They go on forever. They can still have a minimum if they're a right side up parabola, and they can still have a max if they're an upside down parabola. Okay, so now let's move on to point slope form of a linear function. And this is the last part of learning about linear functions before we move into the next module. I'd like to draw your attention to, here is the slope formula. y2 minus y1 divided by x2 minus x1 equals m. And you can see here that what I have done is I have used the slope formula and our literal equation skills to solve for my y's. Okay, you can see I showed you up here that I first needed to get rid of the x's. Well, right now the x's are dividing the y's. So what undoes division is multiplication. So I multiplied both sides of the equation by x2 minus x1. You can see I did that right here, which canceled it on this side, and it showed up over here. And there are many textbooks that still write point slope form of a line like this. Okay? More often than not, you see it written like this. Instead of y2, we just have y. Instead of x2, we just call that x. So in this form of a line, what's important for you to know is x and y, x1, y1, represent a point on the line. Okay? And your m, of course, is your slope. All right? So there's one more thing that I wanted to say about point slope form. And that is, I invite you to simplify this equation and rewrite it in this form. Okay? Whereas we add the y1 to both sides of the equations, which means it's going to cancel it here, and it's going to show up over here. And you rewrite x1, y1 as h and k. Okay? So, and you rewrite your slope, m, as a. All right? So why did I bother to do this? Why did I bother to show you this? I'm planting seeds right now. Okay? This is a very special form of a function that is the same for every single function family. And I'm going to show you some examples in the next page. But I just want to let you know that a is always associated with the slope. It is the slope. Okay? No matter what function family you're dealing with, if you have a number multiplied on the outside of a grouping symbol, that represents the slope. The other aspect of this that's important to note is that h is always associated with the x coordinates, and k is always associated with y. Okay? So they call this transformation form, and every function family has them. Okay? Here are some of the examples that I wanted to show you. For a linear function, this is what it looks like. And what I want you to notice, because we haven't learned about these other functions, but what's important to notice is how they are all the same. Okay? Linear looks just like this. Quadratic looks just like linear, except that it's got a 2 up there. Cubic is the same, except that it's got a 3 up here. Absolute value looks exactly the same, except the grouping symbols are absolute value bars, not parentheses. For a radical function, it looks exactly the same, except the grouping symbol is a radical sign, not parentheses. And here is exponential. I didn't label it, but here's exponential form. Okay? The h is up here with x because that's how you write an exponential function. A is still out here, and k is still over here. And the last thing before we go, I already talked about this in another video, but this is a quick reminder that you can have zeros, okay, in an infinite function, all right? You can have maxes and mins, all right? You can have real zeros, and you can have maxes. You see how this is an infinite function, and yet we have a max here and a min down here. Okay, and I just wanted to demonstrate for you guys really quickly that this is how you would write your answers for zeros, and this is how you would write your answers for maxes and mins. Thank you guys for listening, and I'll see you in the next video.